you a very cool feature of Geogebra. Uh, how to uh, explore functions in the inverses. So let's say I want to know the cosine function, and you know the inverse is not possible um, because it repeats its values. So let limits its domain to um, uh, the interval between 0 to pi. And now I'll try to plot its inverse. So if I say cosine and let's go to this keyboard, here I go for inverse and you see the inverse. Now if you zoom a little bit, some of you may find this perplexing, but to make sense of such plots, there's a good idea is to also plot this line. So this y is equal to x line is very interesting because if you look at the cosine function, the green plot, yeah, you can imagine as if this has been reflected around this y is equal to x line. And you see here is the reflection. So this gives you a very useful way of understanding why one is the inverse of the other and why you need to limit the domain of a function to make it one-to-one. So let's now change this now. I won't change the y is equal to x line. I'll just remove this one and I will let's replace this with secant. Okay, so this is now secant. This is x and I remove this. Yeah, now this is secant. So I did not change the domain because secant is just the reciprocal of cosine. And now I will try to plot secant inverse. Yeah, secant inverse x. You see the exact same pattern. The green one is the secant, limited to that interval between 0 to pi. You have this line y is equal to x, and the blue curve is the inverse. I think I messed up something. Yeah, secant inverse. Oh, this is also interesting because although I typed secant inverse, it automatically changed it to cosine inverse 1 over x. Maybe that is more readable. But I asked for secant inverse. Okay. So that was it. Thank you.